Then we introduced also, and this is described in the second patent which is pending, this is a Polish patent, strong nitrogen bases, which, apart from the catalytic function, contain also initiating function. I mean, OH groups or primary amino groups. That's also, I think, interesting proposal for the PLA used then in biomedical field. First, in Warsaw Technical University, studies have been started on a lower scale. Namely, we optimize this process with various initiators using multi-max system with infrared control towards the consumption of lactite. And also separately, this is polymerization in the small glass vessels, or in 1 liter stainless steel reactor we constructed in one of the former Ministry of Science and Higher Education projects in Poland projects. Here is an example of series of infrared measurements. You can see changes of intensity of, from one hand, of lactite band, and on the other hand, pure lactite band growing during the reaction. And this is kind of a optimization surface allowing to choose to focus, to tune the best conditions for high molar mass synthesis in a given polymerization conditions of polylactide. Another problem which is are under study in Warsaw is using of glycerol. Glycerol is, as you know, byproduct in biodiesel production, and there is overproduction, of course, of glycerol. And this is what we propose. We, I mean our consortium, is using as an initiator. First, we hyperbranch polyglycerol has been prepared, and this on this hyperbranch polylactite, star-shaped polylactite has been prepared. There are some data. I have no time, of course, to discuss in detail this. Another project which is also carried out in Warsaw is synthesis of block copolymers. The first block is prepared by polycondensation, and the second block by ring opening polymerization of lactite, which increases, how to say, palette of the final products we are proposing. Concentrating also a little bit on possible biomedical application, this picture shows microspheres prepared from polylactide located on the aorta walls on red. And they are located in quite a stable way. And eventually, this kind of polylactide with microspheres with simvastatin allowed to reduce completely inflammation which was induced it was induced in rats. Without simvastatin, inflammation and injuries of endothelium were not noticed in the studied case in 60% of animals. Another example of application of polylactide microspheres related to polylactide scaffolds, in bond forming, in formation bond forming cells in living cells culture. So this gives certain imagination of possible area of application of polylactite in biomedical area. Concentrating now on the synthesis of aromatic aliphatic polyester, this process is realized in two-step synthesis. First, ester exchange proceeds, and finally, polycondensation leading to the high molar mass polymer. And the mixture of this aliphatic dicarboxylic acids this is simply byproduct from one of the processes realized by Polish chemical industry. Of course, there is a certain problem because not always there is the same composition of these aliphatic acids. Physical-chemical parameters for this kind of polymers. Melting temperature, unfortunately, as you can expect, is not very high. It's a little bit exceeds 100 degrees centigrade. Enthalpy of melting is also not very high, which points to the not high degree of crystallinity. Glass transition temperature minus 25. The onset temperature of thermal degradation, 1%, is 330 degrees. Molar mass this is, I think, value 25,000 or maybe a little bit higher. In other examples, I know this allows to prepare this polymer practically, flow index. However, the molar mass distribution is also quite broad. These photographs show reactor 30 liters used for production of this polymer in the Institute of Biopolymers and Chemical Fibers. Smaller reactor, almost 1 liter volume, granulated polymer, strands of this polymer, and non-wovens. I think tomorrow we'll learn more about non-wovens. And finally, of course, chemically pure polymers are not the final products able to practical application, require certain further elaboration. Catalyst has been deactivated, but this is rather a problem, metal-based initiator of catalyst, not the catalyst we are going to introduce. Thermal stabilization, certain processing aids, hydrolysis prevention, and antioxidants, degassing, control of dispersity of molar mass, of monomer content, and so on, so on. So I'm finishing. Okay, and this is example of microphotographs showing how these polymers crystallize. Interesting is that crystallized form fibrous secondary structures here. And this is a summary. This is a list of processing means which eventually allow to apply polylactite and this aliphatic aromatic ester But this concerns rather these high tonnage, high scale products, but because in the case of biomedical application, these are certain additives used in this kind of polymers. Processing would be not advisable, I think. So, thank you for your attention.